This video is going to cover Unit 26, Section 1, Areas of Rectangles. Okay, so let's get an example here. So I've got a rectangular figure here, and we know that a rectangle, all the corners are 90, opposite sides are parallel, so we've got width and length. So the area is equal to width times length. Seems simple enough. Now, let's say we've got a figure something like this. Let's go to here. Let's go all the way to there with it. I think this is, yeah, this is pretty similar to the one on page 655 at the top. It's not exactly the same, but it's similar. And there's a connection there. All right, so let's say you got a figure something like this right here, and this side is 10, this side is 12, this side is 8, and say this side is 15. So we need to find the area of this. Well, because this line, these 2 points right here, line right up. So we can just find this one and add them together. So this one is 120, and 15 times 8. Oh, I did not plan on that. This one is 120 as well, so the whole area is 240. Amazing. Now, let's look at the top of page 655. See if I can get that picture in here so I can focus on it. Ta-da! Let's bring it in. All right, so we've got a figure right here. Okay, now this time the points don't line straight up. All right, so there's several different ways we can look at this. We can look at this problem. We could take this rectangle right here, draw a line down here and right there, and make a rectangle with just this part right here. Then we'd be left with a couple rectangles for this one down here. Or another way to do that would be to break it up the way they do it, right there at the very bottom of that. So you've got 3 rectangles here. So we know that we're 44 feet, oh nope, they just do decimals here. So 44.75 feet here, and then 18 feet from here to here. They get that from right there, 18 feet, and then we draw an imaginary line across here, parallel to that one, and that distance from there to there will be the same, so that would be the 18. That's where the 18 comes from. And then, of course, we've got 22.5 feet right here. That comes from right here. So if we draw another parallel line parallel to this line right across here, we take the 38 feet 6 inches and cut off 16 feet, and what we're left is 22 feet from this point to that point. That's where that comes from. Then, of course, the 16 feet's left right there. So what we're left with is 3 rectangles here. All right? Now, they've changed them all to decimals, so don't have any inches left. So this first one is 44. Oh, I'm writing that out of the screen. I didn't realize that. This first one is 44 42.75 times 18. And then we've got 72 even times 22.5. And then we've got the last one right here, which is 42 times 16. So 42 times 16. So we would multiply all these together and then add them up. So let's see here. You can do that right in your calculator. 44.75 times 18. And if your calculator understands the order of operations, you just say plus 72 times 22.5 plus 42 times 16. And you get quite a bit. 3,097 and a half. And that would be, oops, square feet. I probably should edit this and do it again, but I'm not going to. Those are my mistakes. Anyway, so the idea here is to take a figure like this right here and to break it up into something like this. Now, like I said, there's definitely more than one way to do this kind of a thing. You could also draw lines this way, auxiliary lines. We'll call those auxiliary lines. I could draw a line here that's parallel to this one, and I could make a rectangle here, and then draw another line there that's parallel to that one, and make a rectangle here, and then that would leave me with this, so I would have 3 again. But the way I did it originally, I would draw a line here, make this one rectangle here, and then I would have to make a small rectangle here, and then this one here. There's many different ways to do it. But the idea here is to use what we would call auxiliary lines to break it up into smaller pieces that we can use the formulas that we know in order to solve it.